Hello, hope you're well and ready to do some math. We're going to do a pre-algebra topic today, multiple fractions, but I'm going to focus on why it's okay to cancel common factors when multiplying fractions. You might already know how to multiply fractions. You might already know the mechanics. For example, if you see this, you might already know that you can do this and do this to get 3/4. But you may not know why you can do that, so it becomes just a memorization task for you. And a task that is memorized and not fully understood can be taxing on the brain, especially if the task has many steps, unlike this one that has just a couple steps. So you want to understand what's going on behind the scenes that allows you to do what you can do, so that in the rare case that you might forget the steps, you can use your logic and reasoning to figure out the steps on the spot. So that's what the purpose of this video is. So I'm going to explain why the steps I just did for 2/5 times 15/8 are legal and lead you to the correct answer of 3/4. So first I gotta lay down some laws that you probably already know, but maybe you never thought about it in terms of multiplying fractions. So the first thing is, when you have two fractions that you're going to multiply, you are perfectly allowed to multiply the numerators together and the denominators together. Okay, and the second thing I'm going to say is that, and this is even more basic than what I just told you, you can change the order of A and C because you're multiplying them to C and A. You can change the order of BD to D times B because something called the commutative property tells you that you may. Something else you need to know is that any number over itself, except for 0, is 1. You probably knew that. That's just something we're going to use in a second here to show how to do this. And any number times 1 is itself. Okay? So these are all the ingredients we need to prove that 2/5 times 15/8 equals 3/4 through the method of canceling common factors. Okay, so if I start with 2/5 times 15/8, because of the first thing I told you, I can do this. And because of commutative property, I can do this. Change the order of 2 and 15. And I can just leave 5 times 8 the way it is if I want. And you'll see why I didn't move the 5 and the 8 in a second. So now that I have this, I can use this same equivalence that I had up here to rewrite this as 15/5 times 2/8. And now I can work on each fraction separately. So 15 I'm going to factor. It's 5 times 3 over 5. 8 factors is 2 times 4. And I can now, I'm going to write it here, I can now rewrite that as 5 over 5 times 3 times 2 over 2 times 1/4. And because of the n over n equals 1, the 5 over 5 becomes 1, and so does the 2 over 2. And then because of anything times 1 is itself, the 1's disappear, and I have 3 times 1/4, which is 3/4. This step here is actually called definition of division, which I failed to mention up here. Okay, so why did I go about that roundabout way to get the answer of 3/4? Because we already knew the answer was 3/4, and you probably know this method already. It's because this process of canceling common factors is the shortcut, is the summary of what I just did. Every step I just did is a legal step based on some property or law, some eternal truth in math. This canceling was not an eternal truth. It's a shortcut that man made up based on these eternal truths that are spelled out for you right here. So canceling common factors is restating all of these little steps that I just did, how they are legal and how they provide us for an alternate way of multiplying these two fractions. It tells me that it doesn't matter if the 15 is above the 5 or above the 5 in a different fraction. I can still cancel the common factors. It doesn't matter if the 2 isn't above the 8. I can still cancel the common factors. Why? Because commutative property over here told me so. I can forget about the 1 here. Why? Because anything times 1 is itself. Okay, so I hope that helps you understand a little bit more about why we do the things that we do and how mathematicians came up with these shortcuts that we take for granted. Thank you, and see you later. Thanks for watching K109 Math.